notes for lesson 5 cover single replacement reactions. So single replacement reactions is the third type of reactions that we'll cover. Sometimes single replacement reactions will happen and sometimes they won't. So we use the activity series to determine whether the reaction will happen or not. So the definition of single replacement is when one element replaces another element in the reaction. So in this picture, there should be a plus sign between the AB and the C and between the A and the CB. So in a single replacement reaction, you have a single element and a compound. So when you look at the reactants, you are looking for a single element reacting with the compound, and two of those elements are going to switch places, or one element will replace the other. So if we look at our real example here, here's our single element with zinc. It is reacting with copper nitrate, which is a compound. So as you can see in the products, zinc is going to come in and replace copper, and copper gets kicked off by itself. So in the products, copper is now by itself and zinc is combined with the nitrate. So this is a single replacement reaction. If the individual element is a metal, it's going to replace the other metal. Another way that we know what the products will be is to look at the charges. So zinc is +2, copper is +2, and nitrate is -1. When you combine two substances, you have to have a positive charge with a negative charge. So zinc is going to combine with nitrate because zinc is positive and nitrate is negative. And because those two combine, then copper is by itself, then it gets kicked out of the way. So that's another way that you can look at the reaction to figure out what the product will make. You have to have a positive combining with the negative. All right, so the activity series is actually a chart in your yellow packet. It is kind of towards the back of your yellow packet. There's a list of metals, and it says activity series of metals. So the activity series is what you'll use to figure out if the reaction will happen or not. And I can't remember if I changed my typo in your notes packet, but that's why this below is crossed out and changed to above. So when you're looking at the activity series, the more reactive metals are at the top, the least reactive metals are at the bottom. So if you look like silver, platinum, and gold are towards the bottom, those are used in a lot of jewelry, so we don't want those to be reactive. Whereas at the top, lithium, rubidium, potassium, those actually react with the moisture in the air, so those are highly, highly reactive. So when you're looking at a reaction, if we look at this example here, iron plus copper chloride, iron is a metal, and iron is trying to replace copper. So if you look at your activity series, you would find iron and you would find copper on the list. So what you're looking for is the single element above the one that it's trying to replace? So if iron is above copper on the list, iron is strong enough to kick copper out of the way and to make this reaction happen. So iron is, in fact, on top of, or higher up on the list compared to copper. So this reaction will happen. So iron is going to replace copper, copper gets kicked out of the way, iron would then combine with chloride, and here copper is by itself. So when you're looking on the activity series, you want to see if the single element is above the metal that it's trying to replace on that activity series list. All right, if we look at the next example, copper is trying to replace aluminum in this reaction. So if you find copper on the activity series and you find aluminum, you will notice that our single element, copper, is not above aluminum. So copper is not strong enough to kick aluminum out of the way. So literally nothing will happen. You will have no reaction. If there is no reaction, then you don't have to write the products because the reaction won't form any products. So then you would only write no reaction. All right, so here are some more examples. I'm gonna go through each one. So take some time to pause the video and try them on your own before you check and listen to the rest of it. This activity series that's shown here is slightly different than the one in your packet, but it will work for the examples that we have shown here. So again, take some time to pause the video to process on your own and then come back to hear the answers. All right, hopefully you've taken time to pause the video. So for the first example, magnesium is trying to replace iron. So if I look on the activity series, here's magnesium, here is iron. So my single element, which is magnesium, is higher up on the list than iron, which that means that magnesium is strong enough to replace iron. So this reaction will happen. Magnesium is going to then combine with oxygen. When you form a new product, you have to go back to the individual charges. So magnesium is +2, oxide is -2. So in this case, it would be MgO. And then iron gets kicked off by itself. So this would be your skeleton reaction because the reactants will actually happen. But now we have to balance the number of atoms on each side of the arrow. So if we look, we have 1 magnesium on the reactant side, 1 magnesium on the product side. We have 2 irons on the reactant side. So I'm going to put a 2 here in front of the iron on the product side. And then I have 3 oxygens on the reactant side. So I need 3 oxygens on the product side. That changes my magnesium. So then I'm going to add a 3 here. So that would be your final balanced equation. All right, let's look at the next one. Gold and aluminum. So gold is my single element. So if I find those on the list, here's gold and aluminum. Aluminum is up here. So the single element, which is gold, is below aluminum. So gold is not strong enough to kick aluminum out of the way. So literally nothing will happen. So we're just going to write no reaction because gold is not strong enough to kick aluminum out. All right, the next one, we're comparing sodium and potassium. Sodium is up here, potassium is right above it. So because the single element is below the one that it's trying to replace, sodium is not strong enough to replace potassium, so nothing will happen, no reaction. All right, and last but not least, we are comparing calcium and lead. So calcium is up here, lead is down here. So since the single element, which is calcium, is above the one that it's trying to replace, this reaction will happen. So calcium is strong enough to kick lead out of the way. And so we're going to form our 2 products. Calcium is +2, nitrate is -1. So we would need 2 nitrates. And then lead gets kicked off by itself. And actually, we just have 1 of every element. Actually, we have 2 nitrogens and 6 oxygens, but 1 calcium and 1 lead. So this reaction is actually already balanced the way that it is. So make sure you have your activity series available so you can always check. First, you have to determine if the reaction will happen or not. And then if it will happen, then that's when you write your products and balance your equation.